You really have to do it. See a couple of these where they kind of click, I think. Most kids do get these to click. If you don't get them to click, then you don't stand a chance in a calc class or any higher level math. You got to think about the big picture and little picture. The little picture is what's inside. The little picture, G on 53 is 2x plus 3. The big picture is that you take something and you raise it to what power? The fourth. Well, what do you want to call that something? X. So f of x is x to the fourth. And you'll think about making f of g of x. If you made f of g of x, everywhere you saw this x, you would replace it with 2x plus 3. Yeah. All this right here would go there. And the end result would be that one right there. And you kind of apply the same idea to 54. On 54, what's g? Yeah, it's just the inside. The inside is always g. And the outside, x cubed. Take something and cube it. What else you need to say? Did you say 49? 41. Oh man, there's a lot of parts to that thing, isn't there? It's not that hard though. A is f made of g. So what am I going to put here with this x, where this x and x squared is? We'll take the square root of x minus 1. It says squared and add 1. If you square a square root, what do you get? What's inside? So you'd have x minus 1 plus 1, wouldn't you? Which is x. B is g of f. So I'm going to take this quantity and put it right there. The square root of x squared plus 1 minus 1. What do the ones do? They cancel. What's the square root of x squared? X. Those are actually inverses of each other. C is f of f. That's actually one of the harder ones there is. Because this x right here has to be replaced with x squared plus 1. So it's x squared plus 1 squared plus 1. How do you square x squared plus 1? You FOIL. You'd have x to the fourth plus 2x squared plus 1. And then that plus 1 right there at the end. So it looks like you'd have x squared plus, x to the fourth plus 2x squared plus 2. And let's see, D is probably not going to be anything you can really do anything with. You've got a square root. You're going to replace that x with the square root of x minus 1, and then you take away 1. That's a nested radical. Unless it's equal to something, there's nothing you can do with it. Like if it equaled 2, I could square both sides, right? But it's not equal to anything, so there's nothing you can do with it. What a funny look. You just don't like that thing?
No, I was thinking about the other one. The other one, is that how we write it to get it correct? We just write both parts of it. So g of x is 2x plus 3 and f of x is x to the fourth. On d3.
Yeah.
That's just how because you don't combine them together because that would be the same.
That would be the end result. The result was to find the pieces that make it.
Okay.
But the goal was to find the pieces that make it.
Okay. And can we get 44?
That's probably the ugly one. F of g, so that x is going to become x plus 4 over 2x minus 5. Minus 1. That x is going to become x plus 4 over 2x minus 5. Minus 2. I did get a separate sheet of paper for that one. I would clean that up with the LCD method. What is the denominator that you see? 2x minus maybe? No. 2x minus 5, that thing. Now when you distribute here, 2x minus 5's cancel. You're left with twice x plus 4, which is 2x plus 8. When you distribute here, minus 2x plus 5. Down low, when you distribute, the 2x minus 5's cancel. And when you distribute here, minus 4x plus 10. You just combine likes. Cancel, cancel. Top makes 13. Bottom makes negative 3x plus 14. Apparently you didn't have to find the domain, did you? Nope. That's A. B is g of f. It's the other way around. That x will become 2x, sorry. That x will become 2x minus 1 over x minus 2, and that x will become 2x minus 1 over x minus 2. But it's going to be the exact same way we kind of simplify it. If you're doing B, what you're also doing? X minus 2. Why are we allowed to do such a thing? Why are we allowed to multiply everything by the same thing and get away with it? If you multiply the top of a fraction by x minus 2 and the bottom of a fraction by x minus 2, what are you really multiplying by? 1. We're changing appearance, not values. So all we're doing is changing appearance, not values. Or we can do it the long way. X minus 2's cancel. 4 times x minus 2 is plus 4x minus 8. Down low, the x minus 2's cancel. Twice 2x minus 1 is 4x minus 2. And the x minus 2's do not cancel, so negative 5x plus 10. Combine your likes, you'll have 6x minus 9 up top. You'll have a negative x plus 8 down low. Well, let's see, C is f made of itself. That's getting kind of boring. Emily, do you have the gist of this now?
Yes.
And I'm done. If you got the gist of it down, you can finish it.
It was just simplifying.
You LCD it all day long. It doesn't even take that many steps. Anything else? 66. Are y'all all dreaming of snow and ice? Yeah? Oh, believe me, there's nobody in this school who wants more time off than me. Miss Abbott asked me, you know, what's wrong the other day before she got quarantined. She's like, what's wrong with you? I was like, I need it to effing snow. I didn't say effing either, kids. That's how bad I wanted to snow. I said effing. Teachers are people too, you know. We don't cuss in front of y'all, but behind a closed door, it's a little different. The volume V of the hot air balloon described in problem 65 is given by volume because it's a sphere 4/3 pi r cubed. The radius r is the same function of t as in problem 65. Find the volume V as a function of the time t. Oh, well, there's your radius. Radius is 2/3 t squared. They want me to rewrite this thing as a function of t. So if I replace that r right there with that 2/3 t cubed, isn't it going to be a function of t? Why do we say it's a function of t instead of a function of r? Because its variable is t. So volume as a function of t is 4/3 pi. I'm going to replace that r with 2/3 t cubed. Where's that squared? 2/3 t squared. And that's all cubed. Now that's the setup. What do you get when you, we're going to cube both pieces of this thing. What do you get when you cube a 2? An 8. What do you get when you cube a 3? 27. So 4/3 pi. 2/3 cubed becomes 8/27. And what do you get when you cube a t squared? T to the what? T to the 6th. And you just do a little cleanup. 4 times 8 makes a 32. 3 times 27 makes an 81. Pi t to the 6th. So what that would do is, I guess something is being, oh, it's a hot air balloon. That would give you the volume of the hot air balloon as a function of time, which might be kind of important. You know, somebody's like, so when are you all going to take off? And you're like, oh, about 20 minutes. Of course, you know that from experience, but anything else you want? Okay, fine. I didn't want to help you all anyways. There it goes.
Man, are you supposed to have where doing these things?
Where?
Can
I'm not even stuff. No problems there. Do what y'all actually do. Well, I have no idea what's in the homework. I don't do any of it unless y'all ask me to do it. I glance at it and it looks like an okay problem. I go with it.
I can cancel things that are exactly the same and talk to the bottom line.
But they're factors. If there's a plus or minus sign, if it says x squared plus 4 over x squared plus 3, cancel. Only multiple factors. Like, why can you simplify 16 over 12? Because 4 times 4 over 4 times 3, 4 is canceled. It's about multiplication. If it's not about multiplication, you can't cancel. But guys, yeah, if you cancel wrong, I think a kitten is. Pretty sure that's what it says. There's a little fluffy orange kitten back there that you murder every time you cancel wrong. I doubt much of your homework actually simplified. That's usually saved for a different section. You know you're on the honor system in here, right? I just look at the name and I put a check mark unless there's like nothing done. Have you always wondered why all your homework grades were hundreds? I just look to make sure they're done. That's all I do. Right or wrong.
Well, the way I see it, doesn't do any good if I just cheat on homework, because when it comes time for the test, I'm gonna fail it, and I can't have that, so. But somehow I always still don't do very well on them, so even though I try.
This one, not bad, last one. This is 6.2. 6.2 is one-to-one functions and inverse functions. You know, we don't spend a lot of time talking about definitions of things in classes. Anybody know what a one-to-one function is? What's that? Every x has one y. If you go back to functions, a function, sorry, it's maybe just a little more than that. The definition of a function is every x has at least one y. In a one-to-one function, not only does x only have a y has an x. Every x has exactly one y. Every y has exactly one x. Math books will actually use the word mutually exclusive, which just means your way of saying mutually exclusive is a word that probably everybody ought to know. Does anybody know what it means to be mutually exclusive? Huh? No? Who in here has a boyfriend or a girlfriend? Okay, we got a hand there. We got a couple. Bryce, how many girlfriends you got? One. Girls, twins, how many boyfriends y'all got? One. It's not the same dude, is it? I mean, he wouldn't know. You're mutually exclusive. That's what it means. You're mutually exclusive.
You're not always.
Say, Porter has 3 girlfriends. Porter would not be mutually exclusive. Mutually exclusive means you just see one thing. That's all it means. Mutually exclusive. The functions are one-to-one if we use what's called the horizontal line test to determine. The horizontal line test, it determines if a function is one-to-one. Then we know that.
Instead of asking her, he's cheating on me, I'm gonna ask him.
My first wife wasn't. That's the reason why she's gone. So we use a horizontal line test to see if something's one-to-one. Mutually exclusive. Horizontal line test determines if a function is one-to-one. I was hoping you guys remember more about it because I don't have enough room to write down the definition of horizontal line test. Here's the definition of a horizontal line test. If a horizontal line intersects a graph only one time, function is one-to-one. Only once. What's the graph of x squared look like? U. Where's its center? 0, 0. It's at the origin. It's the parabola. Horizontal line intersects twice. What that means is that a y, a single y value, has how many x's? 2. Is it one-to-one? No. X is loyal, but is y? It's not one-to-one. One of those things we spend like 5 minutes talking about in algebra 1, 5 minutes talking about in algebra 2, and 5 minutes in pre-calc. You expect it to remember the rest of your life. That's the horizontal line test. What's x cubed look like? Snake. Starts slow, ends how? Huh. Is that thing one-to-one? Yeah, it's going to pass the horizontal line test. I don't care how many times you draw a horizontal line through it. The horizontal line only hits it once. It's 1-to-1. Because it passed the horizontal line test. Now, do you remember talking about this in the past? It's a pretty simple concept. Yeah. Anybody need more time? Inverse of a function. Inverse of a function is a function that does the exact opposite of the original. An inverse function has an input of y, an output Most functions you write are like y equals 3x plus 5. You feed it x, right? And it spits back 1. So the inverse does exactly the opposite. And that is kind of the basic idea, that x and y swap places. Only one functions have inverses. Only one-to-one functions actually have inverses. Why could only a one-to-one function have an inverse? Well, if it's not one-to-one like x squared, if you fed it y, which x value is it going to bring spit back? Think about this one right here. If you fed this thing y instead of x, which x value is it going to spit back? That's exactly, Lindsay shrugged her shoulders. Who knows? That's why only one-to-one functions have inverses, because you don't know which x value it's going to spit back. If you just swap x and y, you don't know. Huh?
Probably the positive one.
I can't understand you with math.
Probably the positive one in that case.
Well, maybe. Depends on how the function's written. Yes, if it is one-to-one, you know exactly which x value it's going to spit back. All right, find the inverse of the following one-to-one function. So this is the data or the input, the x's and y's from a function. And we're just supposed to write its inverse. And I have right up there that x and y swap places. That's the gist of an inverse function. X becomes y, y becomes x. So that ordered pair, negative 5, 1, becomes what? 1, negative 5. We just swap x and y's positions. How about 3, 3? Stays the same. How about 0, 0? Stays the same. How about 2, negative 4? We'd have negative 8, 7. Doing domain on these is a lot like when we first started talking about domain and range in algebra 1. Domain is x's and range is y's. I know you guys did domain and range like this in algebra 1. We give you all the pairs and we ask for domain. And all you do is write down the x values. Probably in order. What's the smallest x value of the inverse? Is there actually, up here, negative 8, and negative 4, 1, 3. I forgot to write the domain of the function. I'm talking about the inverse here, the inverse only. No, I just ignored it for some reason. It's all me. I meant to write down the domain of the function, but I didn't. We'll talk about it in a second. The range of the inverse, the y values, the small y value. Yeah, you got to look here. Negative 5, maybe? And 0, 2, 3, 7. Go back and look at the original function. What was its domain? It's the range of the inverse, isn't it? You guys see that? The domain of the original function is the range of the inverse. Why is that so? Swap x and y. If I wanted the range of the original function, I'd look at the domain of the inverse because I swapped x and y. So those are simple. I doubt there's anything that easy on your homework. Maybe I put one in there. Probably didn't. All right, verifying inverse functions. You actually did one of these I talked about on your homework. I don't know if you caught me. I said those two happen to be inverses. Let's see. If f of g of x equals g of f of x, and they both equal x, two functions are inverses. I don't really care to do both of these. Which one do you want to do, A or B? Which one? B? One with the fractions? All right, verify the inverse of f of x is, oh, they're using inverse notation. That little guy right there is red. Inverse of f. So it's actually not called g here, it's called f to the inverse power of x. Inverse of x. Inverse of f. Well, do what they're telling you to do. We'll find f composed of its supposed inverse by making that x what? I need to make this x. Use this idea up here, f of g. Do I need to make this x? Yeah. This is function g, kids. It's the second function. We got what, plus 3? Can you distribute that 2 in? You distribute it to all 3 pieces or just the leading piece? Just the leading. You guys know that. You know, there's a handful of kids that I've seen over the years at 2 times 4 times 8, they'll do 2 times 4 and 2 times 8, and then they'll multiply together. You don't do that, do you? It's the first one. The first one only. It's the same thing you're doing algebra. It's the first one only. So what is twice that half? 1. They knock each other out. That's what they do. You know, if it's x minus 3 plus a 3, which is x. All right, so that worked out. We got the x, didn't we? Now we go the other way around. The supposed inverse composed of f. So when I start writing down the supposed inverse, I encounter an x, and what do I replace that x with? 2x plus 3. Also inside that set of parentheses for that supposed inverse was a minus 3. You just follow order of operations. So if there's a little math you can do in order of operations, you do it. PEMDAS, please excuse my dear Aunt Sally. Is there something you can do in those parentheses? Don't distribute the half before you do the easy stuff. What's half of 2x? X. Are they inverses? Yes. Since f composed of its supposed inverse is equal to the inverse composed of f, they both equal x, functions are inverses. You're wondering why I'm a little more alert today? It's because for the 4th time in his life, my newborn slept through the night. The 4th time, I keep count of this crap. Only been 4 times. All right, anybody got any questions on that other than it uses that funky function notation? It bothers y'all, doesn't it? Function notation?
Basically, we just do the same thing that we were talking about yesterday, where we put
Yep.
in it, and then we
Yep.
find out we're going to put it back in
That's
there.
all it is. It's function composition. Hopefully there's a draw on inverse up next.
And they have to equal each other.
They have to equal x. We're going to skip that one. Theorem. The graph of a function f and the graph of its inverse are symmetric with respect to the line y equals x. Line of symmetry for two functions or two inverses. All right, the graph in figure 16a is a one-to-one function y equals f of x. Draw the graph of its inverse. Now, if you just go back to the idea of inverses, they swap x and y. All they do is they swap x and y. F of x has the following points on it: -2, -1, -1, 0, and 2, 1. What is inverse have? By the way, inverse is that little notion. X to the negative first power. -1, -2, you swap x and y. What's another point on the inverse? 0, -1. And the last point, 1, 2. There's a point on the inverse, 1, 2. 0, -1. And -1, -2. Sometimes it does help to draw in that line y equals x. I don't know that it does or not, but the theorem says we're going to be symmetrical about that line. Now, connecting the dots on this thing. Looks like that. All you have to do is connect the dots. Some of them are pretty easy to draw. Some of them throw me off pretty bad. But you got to connect the dots, and you got to try to have kind of like the same overall idea to it. But the big thing is that you have symmetry with that line y equals x. So at every point you plot is an equidistant to the original function. You want to draw another inverse, or I can make one up.
It would make it really confusing if you have more points, because you have to figure out how to order
Yes.
in order to.
I think there's 4 of them on your homework. Pretty sure there's 4 of them on that homework sheet where you draw the inverse. It's not that hard though. Swap points and connect the dots, kids. Don't overthink it either. Okay, fair enough. We got 13 minutes of class left. Are we at the hard stuff yet? Oh, not really. Find the inverse of f of x equals 2x plus 3. Graph it and its inverse on the same coordinate axis. And the steps are right there, the same steps I taught you in Algebra 2. Step 1 is to replace f of x with y. And in y equals f of x, exchange the variables x and y to obtain x equals f of y. This is exactly what we did last year. First thing about inverses is what do they swap? What do inverses swap? X and y. That's how you write an inverse. Of course, the book's got it laid out nice long speak there. Does everybody know that f of x is just fancy for y? So, make it a y. That's what it's saying there in the first 3 text. Now, that is a y. Start writing the inverse by doing what with x and y? Swapping. So that y becomes an x, and this 2x becomes a y. If possible, solve for y. Is it possible to solve that thing for y? Yeah, of course it is. It's a two-step equation. Subtract 3 and do what? Divide by 2. X minus 3 equals twice y. X over 2 minus 3 halves is y. Now they want us to graph the original function and its inverse on the same plane. Oh, one other thing. That saying y doesn't tell you it's an inverse, does it? Say it's an inverse by using that notation right there. F is an inverse of f of x. Or the inverse of f of x. So they want us to do some simple graphing. This is y equals 2x plus 3. Where's that thing cross the y-axis? Y equals 2x plus 3. Where's it cross the y-axis? 3. And from that point, what does it do? Runs 2, rises 2, and runs 1. That's y. Its inverse is x over 2 minus 3 halves. Where does it cross the y-axis? Negative 3 halves. Which is halfway between negative 1 and negative 2. And from that point, it rises 1. You may not see that. Some of y'all don't like fractions. Anyone understood 1 in front of that x? It rises 1 and runs 2. So it rise 1 unit and run 2. There is the inverse. Now, what line are functions and their inverses symmetrical about? Y equals x. Of course, I'm freehanding here, so it's not going to be perfect. That should be a pretty good approximation of y equals x. And is that the hot dog line? Is that the line you fold over to have equidistant? Any questions on that? All right. Hopefully there's one here where we have to make something invertible. Is there anything in your notes that we have to make invertible? That needs to be talked about. Pay attention to this because this is how you write inverses of fractions. If you see something fractional, it will always be done this way. First off, f of x is fancy for what? Y. Daniel, what's that orange y going to become? Brenton, what's that orange y going to become? First step on inverses, we do x and y, kids. You solve them. Monica, what's that orange y going to become? It's going to become x. It's going to become a purple x. Let's try this again. Daniel, what's that 2x going to become? Y. Kelly, that x down low, what's it going to become? Y. X's become y's. Y's become x's. That's the first step in writing inverse. Second step is to resolve for y. But I know what to do. How'd you handle the nested fractions yesterday? Multiplied by the LCD. Multiplied by y minus 2. The reason you're having an issue with this thing is because it's a fraction, right? Multiplying by the LCD always eliminates what? Fractions. That's what it does. Y minus 1 whole thing. There. You multiply that x by a y minus 1. Is there a cancellation? No. What is x times y minus 1? Xy minus x. Equal. You distribute that 2y plus 1 over y minus 1. There's a y minus 1 up top. There's a y minus 1 down low. What's left? Y plus 1. Huh? Huh? I have no idea what you're saying. Huh? Doesn't make any sense to me. Why would you multiply that by y minus 1 and throw y minus 1 anymore?
Is it because it canceled?
Yes. When you distribute here, there's a y minus 1 up high, there's a y minus 1 down low. They knock each other out of the ballpark. That's the correct next line. So what do y'all want to do next? I have taught each and every one of you this before. Swear I have. Cross my heart, hope to die. What's that for? Well, it's already on the right. It's already on the right, isn't it? What do you want to do, Brendan? You can. It's not going to get you anywhere. When you first learned to do algebraic equations, you had a whole bunch of x's, they were on each side. You had a whole bunch of numbers, they were on each side. You got everything with an x on one side and everything else on the other. You are going to want to move some stuff with y's. You want everything with a y on one side of the equation and everything else on the other. I'm going to leave xy where it's at. What else has a y? Jump that thing around. You want everything with a y on one side of your equation. And you can move xy to the right if you want. I don't really care. But I'm going to leave it on the left. Everything else goes to the other side of the equation. So that negative x jumps becomes positive. Why did I do that? What's commandment number 1? There's a reason it's literally my first commandment in math. Because it makes almost all of algebra possible. It's first commandment. Pull it. What can you pull from the left-hand side? Y. Factoring should be at least your top 3 favorite F word, kids. I know what your first one is. It's got to be up there somewhere. If you pull a y from xy, what's left? X. If you pull a y from negative 2y, what's left? And that open up the position or the ability to solve for y. How? Divide the x minus 2. And live y times crap. Opposite multiplication has always been division. So y is x plus 1 over x minus 2. Now what's that y supposed to replace with so that you can tell the person reading your stuff that it's actually an inverse? F to the negative 1. I meant to talk about that. You're going to see this in your homework. Why is that there? The domain. X cannot be 1. Plain and simple. If x can't be 1, could there be an inverse for that thing? No. The inverse still has the same restriction. X can't be 1. The function's not invertible at 1 because that doesn't exist on the original graph. All right. We won't have time to finish it, but I can talk about it. It's the same idea, swap x and y. Why do they talk about this here? Why is that there?
The graph y equals x squared earlier, didn't we? Look like that. Was it 1 to 1? If it's not 1 to 1, does it have an inverse? Nope. But what? If you throw away, it didn't cover it up. And again, do better here. Okay, fine. What if you throw away half of it? Is it 1 to 1? That's the whole point of that stuff. They'll put little hints on there telling you that that forces it to become 1 to 1, so that you can take the inverse, okay? So don't be freaked out by that. This is an easy one. By the way, what is the inverse of x squared? What's the opposite of squaring? Y equals root of x. Inverses are the exact opposite function. That's it for class, kids. Same boring place, same boring time tomorrow.
And then hopefully out Thursday, Friday, and most of next week. Don't we get Monday off anyways? Hopefully it'll snow Monday. Which, by the way, turn some stuff snow the rest of the year.